In the concept of paging, what you understood is we divide the process into number of pages, and these pages we put into the frames in the physical memory. And whenever we required the pages, we load into the main memory from the secondary memory. That process is called swapping. Now, when we do swap in and swap out, it depends upon whenever we require those pages. So what will happen is, actually, if the process has 10 number of pages, so we are not going to upload, or we are not going to load all the 10 pages into the physical memory or the main memory. Instead, we put those pages which is required right now or which is required in the near future. And whenever we required the more pages, we just swap out some of the pages from the frames of the physical memory, and we load, or we put the new pages into the main memory, and will update the page table. That is the concept in the paging. Now, to take the same concept further, we have a concept which we have to look is called virtual memory concept. What is a virtual memory? So virtual memory gives an illusion to the programmer that a huge amount of memory is available for execution its process. What is that mean? That mean is user don't know that the process is divided into number of pages, and whenever pages is requiring, I am putting those pages into the main memory. So that is not that is hidden with the programmer, and programmer think that whatever my process size is, I am getting the size, the same size into the main memory, but it doesn't happen. Let's say the process size or the program size is, let's say, 10 GB, and my memory size is 8 GB. So I can never accommodate all the process at once or all the program at once. So what we do is we divide the program or the process into number of pages, and whenever we require those pages, we'll put it into the physical memory. And the whole illusion which is given to the programmer, this is called virtual memory. And the space given to a program or a process into the secondary memory is called virtual address space. That is also called logical address space, that we know, right? So the virtual address space is the actual space given to the process into the secondary memory, and it is very means it is definitely larger than the physical address space of that particular process. So for the particular process, the address given into the physical memory is less. So for that particular process, the physical address space is less. Physical address space is less than the virtual address space. So that is the concept behind the virtual address. So virtual address space is more than the physical address space, but it is limited to secondary storage space. So if you'll see this, virtual memory is allotted to a process is these much, and it is very less than the physical memory or physical address space. And this particular virtual memory is in the part of the secondary storage. So what will happen here is the whole virtual memory or virtual address space for a particular process, we assume that the same amount of memory is allocated into the physical memory. That illusion is called virtual memory illusion or virtual memory. To fulfill the concept of virtual memory, we use the concept of demand paging or demand segmentation.